Assalamualaikum, salam sejahtera, and very good morning to the invitees and participants. Alhamdulillah, yesterday's event was run smoothly and successfully. Hope our event today also will run smoothly and success. Let us continue our conference today with interesting sharing from keynotes. But before we start, I would like to inform, kindly ensure that microphone is in mute mode and the camera is open mode during the sessions. Distinguished guests, scientific innovations and problem solving have brought about ease and revolutionized ways in which human life. Here to highlight some human exploration of nature to solve engineering problems or innovations in multidisciplinary engineering disciplines. Therefore, please welcome Dr. Muyideen Oladimeji Abdulkareem.
Good day, everyone. My name is Dr. Muyideen Abdulkareem. I'm from UCSI University, and my keynote speech today at the International Conference on Multidisciplinary Engineering Technology 2022 is topic Biomimicry, the home to engineering problems. Okay. So here is my contents of this short speech. Firstly, we have the definition of what biomimicry is. Secondly, we have history of biomimicry. We also have advantages of biomimicry, applications or examples of applications of biomimicry. And then fourthly, I would show an example of a work research that I have done using biomimicry concepts. And lastly, I'll talk a little bit about my present / my future research. So how do we define biomimicry? Biomimicry is a combination of two words, bio and mimic. So the first one, which is bio means nature or means living organism. And living organisms in form of plants or animals. Mimic means to imitate or to copy or to impersonate something. So when we now say biomimicry can, joining both words, can simply mean using the concept of nature or living organism to solve problems. Biomimicry is an emulation of the models, system, and elements of nature for the purpose of solving complex human problems. That is, you use naturally existing models, system, or elements, and then you use that concept to solve human problems. It is termed as innovation inspired by nature. Whatever thing you innovate, whereby you try to copy nature, it's also being defined as biomimicry. So when we talk about the history of biomimicry, this could date back as far back as the 14th and as far back as the 15th and 16th century by Leonardo da Vinci, whereby he tried to design a flying object by trying to copy the wings of birds. You could see the drawings over here at the top, mimicking birds. The same concept was applied by the Wright brothers in their Muyideen 1903 plane flight. In the 50s, this concept was further developed by Otto Smith, whereby he termed it biomimetics, or popularly called as biophysics. And then in the 60s, we have it improved, or this concept improved by Jack Steele, whereby the term bionic was actually introduced, and this is popularly referred to as cyborg. Cyborg generally means as in a human being who has some parts, arms or legs or whatever parts, which are like a robot. So in this lower picture here, we could see the arm of a human being being replaced by a kind of robotic arm. So what are the advantages using biomimicry? One major advantage is the hyper efficiency. By copying nature, we know that nature or natural occurring things has, will I say, 100% efficiency. So by the time we try to create something to copy nature, then in that format, we can increase its own efficiency. By employing biomimetic solutions, we can ensure that the design is not only efficient, but also hyper efficient and will never disrupt the natural flow of things. Humpback whales have pumps on the edge of their fins, which contributes to their incredible agility. In this case, this is actually an inspiration in the design of wind turbines. And the advantages of these wind turbines includes blades with three-dimensional pumps that alter the flow of air and distribution of pressure. Secondly, wing-like shape of beds for greater lift and minimum drag. That is, having it in this kind of shape reduces the friction that could lead to drag, and also it increases lift. Another example is what we call sustainability. We can come up with solutions that encourage symbiotic and friendly relationship with the environment or with the surroundings. One way to ensure this is to design innovations which are multi-purpose. Keyword, multi-purpose, more than one purpose, and versatile. This building screen system opens and closes in response to sunlight, just as we have our sunflower. As we have our sunflower here, we have a building with geometric screen system. The advantage of this by copying or by mimicking sunflower is that major one is the geometry allows the open and close based on the sun position, which reduces the energy used and increases comfort to the users. So with this kind of geometric screen system, just as we have our sunflower, when the sun comes out, the sunflower opens, and when the sun goes down, the sunflower closes up. So in this kind of geometric screen system, this geometric screen system allows it to open when there's sunlight, and then it kind of repositions itself to the position of the sun. Okay. Similarly, the wooden lattices are aesthetics and they are functional at the same time. The thermal bimetal material expand more quickly in heat to block the sun's extreme heat. Another example is emphasis on climate. This is a termite den. This is a building in Zimbabwe, in Southern Africa. This building is called the Eastgate Office, which is inspired by termite dens. And this kind of building is inspired to regulate temperature and by mimicking the termite den. Constantly rising temperature, environmental degradation, natural disaster are consequences of climate crisis that we are facing. Instead of waging a constant war against climate to hold the nature at bay, continuously expending energy by the use of air conditioning, our intervention can take advantage of local weather and build with vernacular material, just as we can see in this termite den. So in mimicking this termite den, the advantages that we have for this particular building is that with this, we can maintain a comfortable temperature constantly. We have large chimneys that allows for cooling air to come in, and then we have slabs that can retain coolness. Another advantage is by studying survivors. Over here we have gecko, and as we all know, wall gecko are animals that can climb walls and can even climb surface of the floor and hang upside down. So gecko climbs vertically with the help of very tiny hair-like strands. These hair-like strands are at the bottom of their feet. And these hair-like strands, it creates a kind of sticking force between the setting and the walls in which the gecko is climbing. So by doing this, human beings now have started mimicking what we call a kind of climbing pad, which is capable of supporting human weight to climb buildings. You see, this is the facade of a building, can climb building. So the advantages include connection of parts through digressive spring that lose stiffness when stretched. So we have an enzyme of climbing pad inspired by the feet of gecko. Now we can now talk of the applications and examples whereby biomimicry is being applied in our everyday environment, in our everyday stuffs. So the first one here is in aviation or in the military. So in aviation, we've all seen, or we could all see, or anytime we see a plane, we can take note of the shape and how the orientation of the elements in a plane wings looks like. When we look at this and we look at the wings of a bird, you'll see that there's a lot of similarities in the orientation and the shape of the wings. Similarly, when we look at the fuselage of the plane, you could see that the shape and the orientation, everything looks like this shark. So we have shark in water, we have plane in the air, they are both fluids. So the kind of movement, or the movement in shark, movement of shark in water could actually lead to mimicking and designing the fuselage of a plane in this form. Also, in aviation and military, we have this stealth plane military jet fighter B-2, and this is actually mimicked in the form of a falcon bird. Falcon birds are known to be very stealth flying birds, which actually flies with very low noise, and they're actually so stealth that in most cases their prey does not even see them coming. The next one over here is we call space exploration, whereby we have a shuttle plane on another plane. Seats being or mimicking these birds on the right hand side. So this issue of this space shuttle is to actually increase the initial velocity of the space shuttle, so that it's going to have it's going to make it easier for it to get into orbit. Another example is the high-speed train. This is common in Japan, and due to the problem of noise, due to the problem of speed so much, the Japanese engineer came up with the idea of designing the front part or the nose of the plane like the beak of the kingfisher. Kingfishers are fish or are birds that actually hunt fish inside the water. So they dive into the water and they are able to pick the fish, and they cause little vibration, little noise, and the prey are unable to know that they are actually coming. They don't see them coming. So by doing this, the noise from this bullet train is reduced drastically. It moves 10% faster, and it has 15% less noise. Another example is these fireflies, and we have our LED lights. Fireflies, they have abdomens in this kind of corrugated surface, and with this, scientists came up with the idea of having a kind of corrugated surface over our conventional LED lamp. And by doing this, they were able to increase the brightness by as much as 50% and reduce heat. Okay, my own personal work that actually involve kind of biomimicry is production of bioconcrete. Bioconcrete actually involves using microorganisms that calcite producing to increase the properties of concrete. As we all know, calcium carbonate is the main ingredient used in production of cement. So when we have these microorganisms inside concrete, they produce calcium carbonate, and this calcium carbonate tends to fill the tiny pores or voids inside the concrete. So by filling these tiny pores, it increases the compressive strength, which is the most important property of concrete. It increases its porosity. It improves its porosity, and it also improves its permeability. So in this study, we did not only produce bioconcrete to increase the compressive strength, but we actually checked varying atmospheric conditions that could actually affect the metabolism of bacteria. And this metabolism would have an effect on the production of calcite carbonate. And this production of calcite carbonate would have an effect on the compressive strength of the concrete. So here at top here we have the relative humidity varying 50%, 72%, and 92%. And also we have the temperatures. We have 10%, 26%, and 40%. 10 degrees, 26 degrees, and 40 degrees. And down here we have sunlight exposure time, 2, 5, and 8 hours, and we have wind speed of 0, 3, and 6 meters per second. So with these two, each of these, we have two different bacterial concentration added. So for the first set of graph is the lower concentration of bacteria. This second one has higher concentration of bacteria. So from here we can see that this is a normal concrete without bacteria. This is a bioconcrete, concrete with bacteria. Normal cured inside water. And then these other ones are ones that are cured in different atmospheric conditions. So from here, we can see that as the relative humidity increases, the compressive strength as well increases. And at the same time, we can see that as the temperature increases up to 40 degrees, the compressive strength of the concrete increases as well. So with this, it actually confirms findings from micro or biosciences literatures, which shows that the optimum temperature of Bacillus subtilis in this case is about 37 degrees. So which makes 40 degrees to be the temperature that has the highest metabolism of the bacteria. On the lower part, we have increasing sunlight exposure reduces the compressive strength, which means that it reduces the metabolism of the activity of the bacteria, and which is similar to what we can see in literatures, which say that ultraviolet rays reduces the activities of bacteria. So with this also, we can also see that increasing wind speed also increases the compressive strength of concrete. Okay, so from here we can see how all these atmospheric conditions, the relative humidity, the temperature, the sunlight exposure time, and the wind speed, how these four parameters affect the bacteria and the activity of bacteria, which in turn affects the compressive strength of concrete. So for the last slide, which is for my present study and for my future study, is actually based on what we call modular construction. This is a building, is going to be about 10 floors, and this building was actually completed within 28 hours, and it took them 28 hours and 45 minutes to complete. In modular constructions, you can see that we have modules like units, and this construction is done by actually fabricating or casting each of these modules inside the workshop and then bringing all these modules to site and arrange them. A typical layman example that we can actually use to exemplify this is the arrangement of Legos that kids used to play. So that is like also a small scale form of modular construction. So in this, because these items are being joined together on site, and this is actually far different from conventional precast concrete, because conventional precast concrete just deals with the members or the elements, the beams, the columns, the slabs, just all brought in pieces, and then those ones are arranged. But in this case, we have the modules, actually brought to site and arranged. And this we have the elements are bigger, consist of so many elements, and also this is also faster. So it has the advantage of being faster. It has the advantage of being less labor intensive. It has the advantage of being safe. It also has the advantage of high quality control, because since it's casted or is fabricated in the lab, the quality control can easily be done. However, the one major problem with this type of construction is the earthquake resistance of the building. So based on this, I'm looking at how we can use, or how can biomimicry be applied to this kind of building to mitigate the effect of earthquake on this type of building. So by looking at naturally occurring things, organisms, naturally nature, to see how biomimicry can be applied to solve or to improve the earthquake resistance of this type of building. Okay, thank you very much, and I'll be happy to welcome questions.
Thank you, Dr. Muyideen. Very nice and interesting sharings.